r factorial into n minus r factorial. All right, so we're going to, factorial looks like an exclamation mark. If I say 5 factorial, it means 5 times 4 times 3 times 2 times 1. And that means multiply all of them. 5 times 4 is 20. 20 times 3 is 60 times 2 is 120. Therefore, 5 factorial is 120. If I'm told to write 10 factorial, sometimes it becomes so burdensome that you have to find your calculator. So 10 factorial will be 10 times 9. I'll keep multiplying until times 1. All right. And then I know you can put it in your, by the way, I don't want to say I know you can do it in your calculator. So let's do it with our calculator. How can I find 5 factorial with my calculator? So I don't want to assume you know. Okay, let's do that. So anytime I'm told to evaluate factorial, in fact, I can evaluate it by hand. But when I say 10 factorial, it becomes too cumbersome. Okay, so it means that there are some of them I can do, I have to do with my calculator. So I put in 5, I go to MATH, math, and arrow to probability right here, PRB. I can go back and do that. Number 4 is factorial. So 5 factorial is 120. So that's just what I found by hand. But what if I'm told to find 10 factorial? 10, go to math, arrow to PRB. Number 4 is factorial. That's a long digit number. That's 3,628,000 and so on. What if I'm told to find a 19 factorial? Then it becomes a whole lot of large number. 19, go to math, arrow to PRB. Number 4, and hit enter. Okay. So now if I'm told to write 19 factorial, it is 1.22 times 17 to the power 10. Okay, let's write it in. I want you to know that this is scientific notation. So this is scientific notation. So I can say 1.22, 1.22 times 10 to the power 17. Why am I saying this? There was a test where somebody was told to calculate 19 factorials. I believe this person was never in class. So she never understood what this is. E here means scientific notation. So it actually means times 10 to the power 17. That's all. That's all. It's not even a big deal. So this student said there is no real solution. So the answer to this student is that there's no real solution. But that is false. The solution is so large, that's all. It's a large number, but it doesn't mean no real solution. Anyway, so whenever you see this, it means scientific notation, by the way. So we just explained factorial. Let's go to permutation. So what is the definition of, okay, let's start. All right, so we're going to start with combination. We have already said that in combination, order is not important without regards to order. Another way of saying the order is not important. Let's do let's do something simple. In how many ways can you arrange A, B, C if order is not important? If order is not important, then ABC is equal to ABC. Because even if I say ABC, CAB, CAD, okay, CBA, they are still going to be ABC. So if order is not important, then ABC is equal to ABC. Order is not important. But I want you to note this because we shall soon get to permutation. In combination, order is not important. So it doesn't really matter how many ways I can write ABC. ABC is ABC. Okay. So combination, order is not important. That's why I want to make sure you know what order is not important is. Okay. Suppose I have 7 pairs of shoes and I want to take 3 at a time. And I want to take 3 at a time to go and donate to charity, no matter where charity. I know that the formula for combination, let me make it bigger. I know that the formula for combination says n combination r is equal to n factorial all over r factorial into n minus r factorial. All right, so I will have 7 factorial, the number of shoes I have at a time, all over 3 factorial into 7 minus 3 factorial. So this is how I'm going to do it. And don't worry about doing it with your by hand. But anyway, I'm going to just show what it is. 7 times 8 times 6, 5, 4, 3, 2, 1. And then I'm going to do 3 factorial, which is 3 times 2 times 1. 7 minus 3 is 4 times 4 times 3 times 2 times 1. Times 2 times 1. All right, just if I cancel from here to here, I now have 3 and 2. 3 times 2 is 6, so this and this will go. Therefore, my 7 combination 3 will end up being 7 times 5, which is 35. So there are 35 different ways I can choose 3 shoes out of 7 to go and give to charity. There are 35 different ways. Okay, so let me do that with my calculator. So I am going to get my calculator, turn it on. How do I answer a combination question with my calculator? So I will put in n. What is n? The total, the sample space. Remember that sample space is the same as the count, the same as population. So here you're going to hear sample space a lot. So 7, you don't put combination there. Go to math, arrow to PRB. I hope you're doing it with your calculator. And then I want you to see that combination is number 3. 7 combination, what number? 3, which means I can actually use my calculator to solve combination. My calculator, I can solve any problem in combination. Therefore, if I do it by hand, if it's an easy question, I'll get the same answer anyway. So there are 35 different ways I can select 3 shoes out of 7 to go and donate. Counting principle number 3 is permutation. And then we shall do a combination of all 3 of them. Let's go to permutation. Somewhere our book has permutation. Please, I want you to read. There are so many things to read. Don't wait for your teacher to read it for you. See, we just did an example of combination. We don't really have time to read PowerPoints. So I'm just selecting the ones that are important. I'm selecting the PowerPoints that are important because we don't have time to read all of them. Okay, so do what you can do whenever you have. There are things, if you already know something, then you have to scan it. You don't have to just read in between the line. is the one that you don't know, that you take time and research. Okay, so here is a question. Let's go to this. So see, practice by hand. You can practice it by hand. I hope you see, if you can practice it by hand, you see you already know it. So for combination 1 is 4 factorial over 1 factorial into 4 minus 1 factorial. Everybody look, let me make sure I make this. Anytime you see 1 factorial is equal to 1. Anytime you see 0 factorial is equal to 1. Don't forget that 0 factorial is 1. Because you will have a question like this. 5 combination 2 divided by 0 factorial. For those who don't pay attention, they will say no solution, undefined. Do you see the question? It's always going to be there. Some surprise questions will be there. Sometimes in homework, sometimes in your SCT or SAT exam, whatever it is. You just want to know that from today, especially when you get to calculus, from today that 0 factorial is 1. All right, okay. So I'm showing you this practice. So when you go home, you are the one that's going to do them. We don't have time to do this. So, but I have already done one of them. Is that clear? Okay, next, the last one we need is permutation. So let's see a definition of permutation. So you see that they did a whole lot of explanations for you. Please read this. Please read this. All right. So there are so many applications, DNA. Now we go to permutation, the next counting principle. There are 3 counting principles. Counting principle number 1 is factorial. We explained that. Counting principle number 2 is combination. Order is not important. We come to number 3, permutation. Is the difference between combination and permutation. Remember, in combination, we said, well, let's go to permutation. I wonder why this is frozen. In minutes, we gotta have this. Let's finish this. We're almost done, so I don't have to. All right, so we want to make sure we know. From the definition, we want to know the difference between combination and permutation. So this is permutation here, and I'm trying to pull this down, but it's trying not to pull down. Okay, well, I'll make it smaller. Whatever I have to do for us to. All right. Still trying to get frozen, but now it can freeze. All right, I'll try that again. All right, try that again. That is looking for my permutation beginning. All right, permutation right here is not right. What's going on? I'm sorry, but this is not funny though. It's not funny though. Okay. Go here. Let me see if it's going to like it for me. Okay. All right. Hopefully this is going to work. Okay. Number of permutations of any distinct objects taken R at a time. The number of arrangements of R objects chosen from N objects. Okay, we want to know what is the most important thing. How do I know that a question is a permutation question? That is the biggest problem. This is what students is going to, in fact, maybe at the end of the day, somebody's going to start asking this question. So let's read the definition. According to our book, a permutation is an ordered arrangement. Why? See, it is ordered. An ordered arrangement. Ordered arrangement. In other words, order is important. In other words, order is important in permutation. This is the most important thing to stress in permutation. Because in combination, order was not important when we are talking about it. But in permutation, the definition says it is an ordered arrangement. Therefore, there must be order. Is that clear? So let's actually start talking about those ABC again. Let's get to ABC. Suppose I'm given 3 letters. Suppose I'm given 3 letters and I am told to write the letters ABC, where order is important. Do an ordered arrangement of ABC. I am going to do only 2 or 3 of them. The first one is A, B, C, the way it is. The second one is A, C, B. The third one is B, A, C. The fourth one is, because I haven't even finished, A, B, C is a different order. ACB is a different order. BAC is a different order. You see? And CAB is a different order, and so on. Wow. So how many of them can I even have? So just so you know that when you are talking about permutation, your answer is going to be large. When I was talking about combination of ABC, I had only one combination. Order is not important. But now I'm talking about permutation. It's an ordered arrangement. Order is very important. What am I saying? Why am I saying this? I'm shouting this. I'm sorry if I am, because students don't understand and they misunderstand the meaning of a permutation and combination. And if you don't understand the meaning of the difference, if you don't understand the difference between combination and permutation, then you will never understand the question. You don't know when a question is a permutation. You don't know what is a combination. All right. All right. If a question is a permutation question, that is something that's going to tell you that is ordered. Ordered. Okay. If it is not permutation, if it's combination, something like human beings. Suppose I'm selecting a committee of 5 from a class of 30. I want you to know, first of all, can I even order grace? Can grace be number 1? Can grace be number 1, number 2, number 3? No. So sometimes order doesn't make sense anyway. So another thing you need to know is that if it's a combination, sometimes order does not make sense. Because if I'm talking about human beings and I'm selecting a committee of 5, there is no way grace can be number 1. No matter how partial, no matter how biased I am, I cannot put grace as number 1 member of the committee. Grace is number 2 member of the committee. Oh, Grace, you're number 3 because I love you. You're a member of my class. You're a good student. Oh, Grace, you're number 4. Grace, you're number 5. You know what? Somebody's going to think, is that teacher, is she crazy? But so sometimes when your argument arrangement doesn't make sense, if your arrangement does not make sense, It is permutation, because there's no way you can just select one person to represent a committee of 5. Human beings are discrete. Human beings are discrete. They're accountable. And so, anyway, so by the way, how can I even know the number of permutations here? I can say 3. How many of them? 1, 2, 3. So I can say 3 factorial. So what is the 3 factorial number of ways? Why did I use 3? Why did I use 3? The sample space is 3. So 3 times 2 times 1. 3 times 2 is 6. So actually, there are 6 different ways I can arrange ABC. There are 6 different ways I can arrange ABC. There are 6 different ways I can arrange ABC. I already stopped at ABC, ACB, BAC, because guess what? ABC is different from ACB because it's permutation. ACB is different from BAC because it's permutation. BAC is different from CAB, is permutation. It's not the same in combination. I hope I cleared this, because actually this question is going to be about 3 or 4 in the test. Well, guess what? If you don't understand the meaning, the difference between combination and permutation, it's really going to screw them up. All right. So, all right. So let's actually find a combination of the permutation question. All right. So let's answer a permutation question. Let's go to, suppose I'm told to, I was talking about having 7 shoes before and taking 3 at a time. But I want you to see, in this particular situation, if I do 7 permutation 3, well, guess what? It doesn't really make sense, because it means that I can give it to charity. I can give it back. It doesn't make sense. You don't do that in real life. Therefore, I cannot use permutation for that. Having 7 shoes and giving 3 to charity is not even a permutation question, because I can't even give it to them and take it back. Order is not important there. All right. Anyway, so let's answer a question. By the way, permutation is n permutation r equal to n factorial all over n minus r factorial. So that is the formula. If I am told to find 7 permutation 5, then I got 7 factorial all over 7 minus 5 factorial. All right? 7 factorial is 7 times 6 times 4 and so on. And 7 minus 2 is 2 factorial. So I can just get my calculator. I don't really have to use my calculator to do that. So you can just, let's do it here. 7 factorial is 7 times. Actually, they did it for us here. So, and so you multiply the remainder after you cancel out. And then you have 2,520. Okay. How calculator to do factorial? Let's do that. Is this answer correct? Let's find out. I'm going to get my calculator. I know we don't have time, but we can finish this. So I'm going to click 7 permutation 5, where order is important. 7 permutation 5. So I go to 7, go to math, arrow to PRB. Permutation is number 2. And 5. So now I got 7 permutation 5 with my calculator. I hope you see why I'm doing this today. So that way you know how you have practice. You will practice with permutation. By the way, we need a combination and permutation for unit 3, because binomial distribution, which is in Unit 3, starts with combination. So we must do this today. We're not going to wait for it to be done on a review day, so that you understand combination, so that you will be able to apply it to binomial distribution. All right, so when I hit enter, I see that my answer is 2,520. In other words, there are 2,520 different ways of selecting 5 out of 7. There are 2,520 different ways of selecting 5 out of 7 where order is important. Where order is important. In other words, you can keep on working on it on the order. Last thing we're going to do, we have 2 minutes. Oh, we have 2 minutes to go, but last thing we're going to do, let me just give you this. Suppose you are given this word. There are some words that are, suppose you're given the word smoke, clear, no, it's clear you, I'm talking about clearing you segments. All right. There are some words like Mississippi. My last name could be good. All right. So there are some words you can be told to find the number of ways you can write them. I would like you to try your last name. I'm going to try my last name. My last name is Ezenekwe, Ezenekwe. Don't worry about pronouncing it. But if I'm told to find the how many ways can I arrange this word Ezenekwe, where order is important. The first thing I want to do is count the number of letters in my last name. 1, 2, 3, 4, 5, 6, 7, 8. So I will write 8 factorial, the sample space of the count, over. I will count every repetition. Did any letter repeat? Yes, he repeated 1, 2, 3, 4. Any letter that repeated, you have to divide by that factorial. If none of them repeats, you just have 8 factorial. So now I can say 8 times 6, 7, 6, 5, 4 factorial, divided by 4 factorial. 4 factorial cancel 4 factorial. Therefore, there are 8 times 7 times 6 times 5 different ways of arranging my last name as Ezenekwe. So I'm going to tell you how many it is. So when you want to do your last name, you will do that. 8 multiplied by 7. I'm doing my last name. You can do your last name next time. Times 5. 4 factorial is taken. So when I get my answer, it is a whopping 1,680 different number of ways I can arrange my last name. Okay, let me give you the one that comes out in the test. The one you may see, it wasn't in the, it's not even in the practice test, but it might come out in the test. In fact, it will be in your homework. Mississippi. But I know that. Maybe for tonight. So, first of all, let's spell the word Mississippi. 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 All right. In how many different can we arrange the word? This is in the test, or maybe in the homework. It was in the test last year. I took it out because I don't like the way people failed it, but it doesn't really matter because I am saying it. I don't think I said it last. I don't think I went over it in class, so they really failed the pre-test. So I took it off the test. They really failed the pre-test. So okay. Anyway, so the most important thing you want to do is count all the, what is the sample space? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 different letters. Well, 11 letters, they may not be different. Divided by, is there any repetitions? Yes, I repeated how many times? 1, 2, 3, 4. I repeated 4 times. S repeated 4 times. P repeated 2 times. Therefore, if I evaluate this correctly, I need to use my calculator. I will get the number of ways that, oh, it's actually after 2, but that's okay, we're done. So I am going to get my calculator and evaluate that. So in how many ways can the word Mississippi be repeated or be written where order is important? This is a permutation question. So 11 factorial. So you go to math, you go to PRB, factorial. Number 4, be careful when you hit divided by, you must use parentheses. Divided by. Okay, I better divided by. Then don't forget parentheses because you're dividing by multiple things. Divided by 4 factorial. So go to math, arrow to PRB. Number 4, multiply again by another 4 factorial. 4, math, PRB. And multiplied by 2 factorial. Well, it might be in your test really because I don't always give what is in the exactly what is. So I can just change it, but it's in your homework, by the way. So you're going to see this in your homework. So you go to math, PRB. And then I know if you have questions, you bring. Actually, questions will be coming next week because we want to make sure we cover everything. And then we start getting to the questions you don't understand when you have read the PowerPoint. Anyway, there are 34,650 different ways we can arrange Mississippi where order is important. Okay, so now you have seen this, you will not be asking how to do the ones. You can see book. You can actually see so many other words, and you are told to find different ways to arrange them. Okay, all right. I think enough for the day. Let's see. Do we have any question? Any question? Sorry, I took you beyond the class time, but it's only 3 minutes anyway. Is there any question? I'm going to turn off recording so that